It's altogether volatile. It's going to explode. No, giving me is not going to be an amazing chance to go for that. The thing is, it might be tomorrow. It very well might be during this transmission, and it would shimmer like a subsequent sun above. The James Webb Telescope has recently detected a surprising 250% increase in the brightness of Betelgeuse, the red star located at the shoulder of the Orion constellation. This unusual behavior has ignited excitement for a spectacular display. Some suggest a surge in brightness could indicate Betelgeuse is preparing to go supernova, yet the exact timing remains uncertain. Experts theorize it could happen soon. Join us as we explore the depths of space and unravel the mysteries surrounding this great giant. Betelgeuse has the potential to reshape how we understand the universe. Despite its name not being well known, you likely appreciate its brilliance, a reddish glow shining brightly at Orion's shoulder. Its significance is staggering. If placed at the core of our solar system, its outer surface would extend beyond Jupiter's orbit. This massive star, easily observable, continues to captivate us. Unlike most stars, Betelgeuse visibly changes over time. Classified as a semi-regular variable star, its brilliance fluctuates consistently, hinting at a potential collapse in a supernova. Recently, Betelgeuse has become even more fascinating due to dramatic changes in brightness. On May 20th, 2023, scientists observed a remarkable 142% increase in brightness, followed by a later update showing a 150% surge. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, noted that Betelgeuse is now the seventh brightest star in the night sky, rising from its usual 10th position. From the southern hemisphere, Betelgeuse shines brilliantly in the evening sky, easily visible at Orion's shoulder. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, emphasizes Betelgeuse's importance. It offers a rare opportunity to study the final stages of a massive star's life, providing crucial insights into red giant behavior before they explode as supernovae. When Betelgeuse finally detonates, it could become incredibly bright for about a week, potentially casting shadows at night. This prospect excites both amateur stargazers and professional astronomers. Heidi Morris, a scientist at Los Alamos National Laboratory and president of the Padaro Stargazers and Cosmology Club, highlights the enduring interest in Betelgeuse's brightness fluctuations, a phenomenon observed for centuries by various cultures. Currently, Betelgeuse's brightening cycle lasts about 130 days, much shorter than its usual 400-day cycle. These rapid changes offer astronomers a unique chance to study this cosmic phenomenon in detail, shedding light on the final stages of a star's life. Betelgeuse's unusual behavior began in 2019, when it unexpectedly ejected part of its outer atmosphere. These brightness changes raise questions about an imminent supernova. According to a paper by Dupree and scientists from Harvard and the University of California, Berkeley, it may take 5 to 10 years for Betelgeuse to return to its usual 400-day cycle. Although the star's dimming has shown altered behavior, it no longer exhibits unpredictable fluctuations. Nevertheless, Betelgeuse remains a massive red giant star in the final phases of rapid evolution. As it exhausts its fuel, its core will eventually collapse under its tremendous mass, resulting in a supernova. Predicting supernova events is challenging due to limited historical data and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes, evolving through elements like helium, carbon, oxygen, silicon, and iron. Eventually, it will no longer sustain fusion, leading to gravitational collapse and potentially forming a black hole or neutron star. While some speculate an imminent explosion, historical records suggest it may take time. NASA estimates that Betelgeuse might not detonate for another 100,000 years. Despite the uncertainty, Betelgeuse's behavior continues to captivate scientists. Dr. Sarah Webb encourages openness to all possibilities. Monitoring its fluctuations could lead to breakthroughs, reminding us that we are seeing light emitted over 600 years ago. Betelgeuse may have already exploded, and we wouldn't yet know. Before 1987, astronomers believed only red supergiants could undergo supernovae. However, a massive blue star's explosion in another galaxy challenged this view. Observing Betelgeuse expands our understanding of celestial phenomena. While an immediate explosion seems unlikely, Betelgeuse's behavior reveals fascinating physics. If it explodes, it could be as bright as a quarter or half of the full moon, visible even during daylight and casting shadows at night. Predictions suggest it might be 15 to 25 times brighter than Venus. The event would last about 100 days, captivating space enthusiasts. Fortunately, Betelgeuse's supernova wouldn't pose a threat to Earth due to its distance. However, its explosion could reignite global interest in stargazing. Betelgeuse isn't the only red supergiant. Others like Eta Carinae could explode first. The Milky Way expects a supernova every 100 years, yet none have been observed in 400 years. Still, remnants of past explosions suggest we are due for a cosmic spectacle. Betelgeuse's history, including its dramatic dimming in 2019, continues to intrigue astronomers. With further observations, we may unravel its mysteries, reminding us of the ever-evolving universe and the thrilling possibility of new discoveries. Skywatchers around the globe can easily observe Betelgeuse from their backyards, contributing valuable data that complements observations from powerful telescopes. This collaboration between amateur astronomers and professional scientists highlights the growing role of citizen science in modern astronomy. Observatories like the Hubble Space Telescope and the James Webb Space Telescope are essential for monitoring Betelgeuse's activity, offering detailed insights into its behavior and helping us understand the processes leading to a supernova. The dramatic dimming event of 2019, which puzzled scientists and sparked widespread speculation, turned out to be caused by a massive ejection of material from Betelgeuse's outer layers. This material cooled and formed a dust cloud, temporarily blocking the star's light. This discovery not only solved the mystery, but also provided a rare opportunity to study the star's outer atmosphere in detail. Such events remind us that even familiar celestial objects can surprise us with their complexity and unpredictability. Betelgeuse's potential supernova has broader implications for astrophysics. When it finally explodes, it will produce a burst of neutrinos and gravitational waves, which could be detected by instruments on Earth. These signals would provide a unique opportunity to study the core collapse process in real time, offering insights into the formation of neutron stars or black holes. The data collected from a nearby supernova would also help refine models of stellar evolution and nucleosynthesis, shedding light on how heavy elements are formed and distributed throughout the universe. Moreover, Betelgeuse's eventual explosion will offer an unprecedented chance to observe the aftermath of a supernova up close. The expanding cloud of stellar debris or supernova remnant will be a rich field of study for decades, revealing how such events influence the surrounding interstellar medium. This could deepen our understanding of how supernovae contribute to the formation of new stars and planetary systems, including the role they may have played in the early history of our own solar system. Despite the scientific anticipation, Betelgeuse's fate remains uncertain. While the current fluctuations suggest it is approaching the final stages of its life, the exact timeline is unknown. The carbon-burning phase it may be entering can last anywhere from a few decades to 1,000 years. This uncertainty is a reminder of the complexity of stellar processes and the limits of our current predictive models. Yet, it also highlights the excitement and dynamism of astronomy, a field where new discoveries are always on the horizon. In the meantime, Betelgeuse continues to be a symbol of cosmic wonder and scientific inquiry. Its behavior captivates both experts and the general public, sparking curiosity about the life cycles of stars and the forces that shape our universe. As we continue to monitor this enigmatic star, we remain hopeful that its eventual supernova, whenever it occurs, will provide a spectacular and scientifically valuable event. Until then, The story of Betelgeuse reminds us of the vast, ever-changing cosmos we inhabit, and the endless possibilities for discovery that lie beyond our world.